this video, we'll be talking about PYQs, popularly known as previous year questions. Now, previous year questions is also a good strategy to cover up the entire syllabus. So, we'll be taking up previous year questions that have come up in SSC JE examination in the field of material science. So, let's start. So, let's start with the first question. The strain energy stored in the body due to external loading within the elastic limit is known as A. Malleability, ductility, toughness, and resilience. The correct answer to this is resilience. Actually, this is the definition of resilience. Second one, proof resilience in a member is stored strain energy per unit volume, in whole volume, per unit area, per unit length. The correct answer to this is in whole volume. The definition for proof resilience is strain energy which is stored in whole volume. When we are talking per unit volume, we are talking about modulus of resilience. Okay. Third one, resilience of a material is considered when it is subjected to frequent heat treatment, fatigue, creep, and shock loading. The correct answer to this is shock loading. When a component is subjected to impact or shock loading, then the important properties which need to be considered are modulus of resilience and modulus of toughness. So these resilience and toughness, they actually come into picture when we are dealing with impact or shock loading. Okay, now this is a very good question. This can be asked again, and this has appeared times to time. Moving on, we have our next question. The ability of a tool material to resist shock or impact forces is known as wear resistance, toughness, red hardness, machinability. Well, as I mentioned before, during the cases of shock or impact loading, we consider modulus of resilience and modulus of toughness as two important properties. So the answer should be B, toughness. And if you look at the definition of toughness, well, toughness is also defined as a property of a material to resist fracture due to high impact loading. Now, next question. Steel whose elements are used for the purpose of modifying the mechanical properties of plain carbon steel is called alloy steel, invar, stainless steel, high speed steel. The answer to this is alloy steel. Alloy steel is what? Alloy steel is a type of steel in which there are other elements apart from our basic constituent, that is carbon. Okay, so it is iron plus carbon plus other alloying elements. Now these alloying elements are the modifications which help to increase or modify the mechanical properties of carbon steel. Now what are carbon steels? In that case, carbon steel is also a kind of steel in which carbon is the major constituent, and we say very minimum or actually it is said as no or minimum percentage of other alloying elements. So carbon steel, the major constituent is carbon plus iron. Now if you alloy it or you add some different alloying elements, we get modifications of different properties. Okay, so moving on. Alloy steel contains 36% nickel. Alloy steel containing 36% nickel is called invar. There are a few things which we need to learn. The composition of invar is 36% nickel and 64% iron. Now carbon steel. Next question. The carbon steel is produced by adding carbon into it. Alloy of iron and carbon with varying quantities of phosphorus and sulfur. Purer than cast iron. None of these. Well, the correct answer is B. Now that contradicts my initial statement I said here regarding what is carbon steel, that carbon and iron. But you have to understand that other alloying elements are also present in minute quantities. So when we talk about this in this question, the correct answer should be B, because there are, even if nothing, but at least a minimum amount of alloying elements will be present. There are different reasons for this, but as of now we should know that the correct answer is B. Okay, next question. The percentage of carbon in steel is 0.1 to 0.8, 0.35 to 0.45, 1.8 to 4.2, 0.1 to 1.5. The answer to this is D. As we know from iron carbon diagram, actually from hypothetical iron carbon diagram, for steels the percentage of carbon is limit is around 2.1%. Greater than 2.1, it is cast iron. Okay. Moving on to the next question. Hardness of steel depends on amount of cementite, amount of carbon, contents of the alloying elements, method of manufacturing of steel. The correct answer is B, amount of carbon. As we increase the carbon content, the hardness increases. We should also know the definition of hardness. Now, hardness is defined as an ability of a material to resist abrasion, indentation, wear, and scratch. In simpler terms, hardness is resistance to indentation. This is the definition. And in case of steels, if we start adding our carbon, the hardness increases. This is evident from the fact that steels are less hard as compared to cast iron. Steels in which the carbon content is around 2.1 and cast iron greater than 2.1. As we increase the carbon content, the hardness increases. Next question is a very good question. Dash is added to raise the yield point of low carbon steel. Silicon, carbon, phosphorus, sulfur. The answer is phosphorus. If you add silicon, strength increases, hardness increases. If you add carbon, again hardness increases. If you add sulfur, machinability increases. And if you add phosphorus, yield point of low carbon steel increases. So what I'm doing is I'm also giving you some extra information which might be helpful while solving similar kind of questions. Moving on to the next question. An alloy steel contains more than 0.5% manganese, 0.5% silicon, less than 0.5% manganese and 0.5% silicon, more than 0.35% manganese and 0.5% silicon, less than 0.35% manganese and 0.5% silicon. Generally, the amount of manganese and silicon added are more than 0.5%. So the correct answer to this will be A. Now let's move to the next question, which is alloy steel as compared to carbon steel is more tough, strong, fatigue resistance. The correct answer to this is none of these, because carbon steel is better in case of toughness, strength, and as well as fatigue resistance than alloy steel. Next question, steel which destroys by burning is called kill steel. In steel, the main alloy causing corrosion resistance is magnesium, vanadium, chromium, cobalt. The answer to this is chromium. Now let's also look at what happens when we add manganese. Manganese helps in increasing toughness. If you add vanadium, it helps in increasing hardness or yield strength. If you add cobalt, now cobalt improves my heat resistance. Next one. The atomic packing factor is highest for which of the following cubic lattice system? Simple cubic, body centered, face centered, and diamond cube. The answer is FCC, face centered cubic. The atomic packing factor is 0.74. Whereas in case of simple cubic, it is 0.52. BCC, we have 0.68. FCC 0.74 and diamond cubic has an atomic packing factor of 0.34. The material which is commonly used for aircraft gas turbine is, well, the answer is titanium. Titanium is generally used for aircraft gas turbines because of its high strength to weight ratio. Next one, for steel, the ultimate strength in shear as compared to the ultimate strength in tension is same 1/2, 1/3, 2/3. So this question we need to know some values. For example, the ultimate tensile strength for steel is around 850 MPa, whereas the ultimate shear strength is around 500 MPa. So you can see it is approximately 2/3. So the correct answer is 2/3. Now this question we can remember the values also because similar kind of question was repeated after a few years. So we'll see when we progress in the video. Then let's move to the next part. The property of a material by virtue of which a body returns to its original shape after removal of load is called elasticity. Essential gradient of any hardened steel is carbon, cementite, martensite, or perlite. Answer is martensite. Martensite is the most brittle and the hardest phase of iron. Again, the question which has values to be remembered. Steel containing 11 to 14% chromium and 0.35% carbon is called martensitic stainless steel, ferritic stainless steel, or austenitic stainless steel, or none of the above. Well, there are few values we need to remember. For example, in case of martensitic stainless steel, the percentage of chromium ranges between 11 to 18%. In case of ferritic stainless steel, the range is between 11 to 32%. If we look at austenitic stainless steel, the range of chromium is between 15 to 26%. So based on this, what is asked is steel containing 11 to 14% chromium and 0.35% carbon. The correct answer is martensitic stainless steel. Okay, yeah. So some people might have a confusion that why not we go for ferritic stainless steel, but then there is a carbon percentage also mentioned in this. So if you look at carbon percentage range, the maximum value for this is around 1.2%. In case of ferritic stainless steel, it goes up to 0.12%, whereas in case of austenitic stainless steel, it goes up to around 0.15%. So based on this, what we have is martensitic stainless steel. Next question. Steel containing 18% chromium and 8% nickel is called. Well, again, 18% chromium brings you in a range of A, martensitic, and also austenitic. Both are there. So now we need to look at nickel. If you look at nickel percentage, in case of martensitic stainless steel, the nickel percentage will not be around 8%, whereas in case of austenitic stainless steel, the nickel percentage ranges up to 2 to 10%. So 8% lies between this range, so the correct answer is austenitic stainless steel. So based on these two questions, what conclusions we can derive is, in case of austenitic stainless steel, chromium percent 15 to 26%, carbon less than 0.15%, and nickel 2 to 10%. We need to remember these values. Now next question. The ultimate strength of a steel in tension in comparison to shear in the ratio of. Now similar kind of questions we have encountered before. One question which was asked is exactly same as this, in which I asked you to remember the values. For example, the ultimate tensile strength of steel in tension, UTS somewhere around 850, and in case of ultimate strength of shear will be around 500. So this gives you around 2/3 of the value. Now we should look at what is asked. Here it is asked ultimate strength of steel in tension to shear. So the correct answer to this should be 3:2, because if you look, tension should be at the top, so this value is more, so 3:2. Now steel containing pearlite and ferrite is tough, hard, soft, ductile. The correct answer is again C. Pearlite is a soft phase. So pearlite is not a phase, actually it's a phase mixture of alpha and Fe3C. So pearlite is soft. So the correct answer is soft. Steel with carbon below 0.8% is called hypoeutectoid steel. If you look at the classification of steels, then 0.8% is eutectoid, less than 0.8 hypo, greater than 0.8 is hypereutectoid. Okay. Hardness of the steel depends upon the amount of pearlite, ferrite, cementite, martensite. Hardness of a steel depends upon the amount of pearlite, ferrite, cementite, martensite. Cementite. Now this is a good question. Why? Because most of you would answer martensite, because we have encountered a similar kind of question before. But then you need to understand that what we are talking about at this point is the hardness of a steel. We are talking about hardness of steel and not hardened steel. So if you look at hardness, the hardness varies with a varying amount of carbon content. And if you can see, cementite is actually Fe3C, which is 6.6% of carbon by weight. So The hardness of steel will depend upon the amount of cementite present. Now, if I'm talking about hardened steel, in that case, the correct answer would be martensite. That's all. Thank you. Now, next video, we'll see another 25 previous year questions and I'll try to answer them.